Hello, everyone, and welcome to the live stream. Till this point of time, we have done a lot of webinars, and then we have done a lot of live streams where we talked about a lot of different aspects of development, right? So this one is going to be a little different. We're not going to talk much about development. We are going to talk about a little bit of testing today. So let's think about testing our code. We would have developed some code apps and stuff, and then we want to test those CorDapp. So how do we test as a developer? It's looking at it from the developer point of view. So that's what we'll be doing in the next 45 minutes to an hour. So my name is Ashutosh, and I'll be taking you through the entire session today. And I also have Arena here. She is out there on the chat, and she's here to help you guys with all your questions that you would put on the live chat. So feel free to put anything that you do not understand, you want more information, and Arena will be able to help you out. In the meanwhile, I'll also be looking at the chat from time to time and try to answer as much as I can. But yeah, Arena is there all the time looking at the chat window for you guys. All right, so let's get started. All right, few of the references for you guys before we start. So you know what's the YouTube channel is, you're already there. And if you're a CorDapp developer, a great place for you to be is the Corda Ledger Slack. So if you haven't signed up to that, just go to slack.corda.net and you could join a community of over 8,500 CorDapp developers. And then we have the Corda docs where you would find everything about Corda. All the different aspects of Corda are documented over there on the Corda docs. We have a free training site. You're new to Corda or blockchain as such, it will provide you a good journey, kind of an experience where you could start learning blockchain and eventually Corda in a bottom-up approach, which is learning simple things first and then learning more complex things afterwards. And then we are all developers, we like to look at code, so probably most of you also would like to look at the code of the platform, right? So that's where Corda is open source and you would find all the code in the GitHub repo. You want to talk to us, you want to contact us, it's devrel@r3.com. You could email us. And then if you're a Twitter guy, we also have the Twitter handles for you, which is @Corda blockchain and @inside R3. And do use the hashtags #Corda and #R3. All right, with all that behind us, let's get going with the session. All right, so when we think of testing, right, so there are a lot of different aspects to testing. It could be like unit test, integration test, end-to-end test, you are having UI test, and then a lot of other things like which comes under the QA's perspective. But what we are going to do today is we're not going to talk much about the testing from the QA perspective, but what we are going to do is just look at the two things at the bottom of the triangle there of or the stack that I would say. We have unit test and integration test. This is something a developer should be very much conscious of while he writes its code. It's always a good thing to develop in a TDD approach, right? Test-driven development approach. So first you write your test cases and then you write all your code according to those test cases, so that once you have all your code and your test cases pass. That's really important from any development perspective. So let's look at them. Let's look at how we could test our different components that we write, like our states, our contracts, and our flows. And we'll also look at how we could do an integration test. So if you test the state separately, you could test the contract separately, you could test the flow separately. But how do we test all of them together? How do we like have a node and then you could fire a flow and then it just interacts with the state and the contract, and then the flow returns you something. So how do we just test all of them? That's coming under the integration test part, and we look at both of these today in the webinar. All right. So yeah, unit test is mostly what we do in our boot camps. You would already be aware of all these things while we do all our boot camps, and if some of you would have already attended them. So what we do is we develop each of these different components, which is our states, contracts, and flows, and we have certain which we have certain tests already written, and we develop in line to those tests. We try to make sure that whatever we write in such a way that all our test passes, right? And once we have all those tests that have passed, we assure that whatever code we have written is actually correct as per our assumptions. Right, so that's what unit test is. An integration test we already talked about. What we'll be doing today in the integration test is we'll use one of the test DSL things which is out there for which is used in Corda to do integration test, which will sort of spin up nodes in the IDE itself, and then you could actually trigger flows using the nodes RPC shell, right? Using the nodes RPC or the Corda RPC ops which you get out of the node. So that's what we're going to see. We'll have all these RPC methods. We will basically trigger the flow, and then we'll do a vault query and see whatever the flow was supposed to do is actually replicated in the vault or not. Yeah, so that's what it is. So let's look at each of these one after the other. You would have seen these classes, specifically the unit tests classes, which is our tests in state test, the contract test, and the flow test. But we haven't done a good job in explaining them while we do them in most of our in-person sessions. But because of time crunch, because we need to complete our boot camps in as much lesser time as possible, we don't go into the details of the tests. But today, that's what we are going to do. We have kept this session separately for that, and we're going to look at all these test cases that we have written and what exactly are they doing, how are they written, right? So so before moving into a few more parts of integration tests, let's look at all these things from the code perspective. So I'll just open up the IDE and try to explain what all these things, all these different test cases do. Right. Yeah. So pretty familiar to people who are not new to Corda, people who have been on Corda for some time. So I hope most of you guys would have been through this particular um, CorDapp, which is the Bootcamp CorDapp, the token CorDapp, which we generally give you most of the examples about. So we have all these test cases here, right? And let's look at them one after the other. What are we exactly doing with the test with the state test? Um, it's not very much different from a general JUnit test case, I would say. Specifically, the state test, it's just testing a sort of simple POJO, right? It's not doing anything more than that. So there isn't much that we want to show you on this one. But one thing that I would just point out is if you look at the state, right? I have already implemented that so that we don't spend time doing this. So if you look at the state, the one thing that's different that is uh, from the point of Corda is the party class, which is an API of Corda. And you know that the party class is actually, if you just go inside that, if you can, yeah, it's not just a simple class. Like, it has other things like the party certificates, public keys, and all these things. So this needs we can't just create a class of party, right, just by saying party equals to new party or something. So we need to have um, some sort of help from the libraries which will help us to create a party. So that's where the test identity comes in. We could create identities, test identities, to do our JUnits, to do our JUnit tests using the test identity class. That's again a part of the Corda's testing library. So whenever you want to have a party in your test cases, and you want to test one of your test cases, and you want an access to a party, then you generally use the test identity, and then you could generally pass in some legal name which is in the format X500 format, and that will return you identity through which you could get the party using the get party class, and that will give you the party. Now that's all we have here. Other than that, what we are doing is just general things that we do in any test cases, right? So like, for example, if you look at this one, we're just testing if our token state has the proper getters or setters or not. So just putting in certain um, assert statements, and then checking them using the getters. So if we do not get an error, that means we have the correct getters and setters, right? So not much other than the fact that you need a test identity to be able to test your test classes, and you might want to test this particular method, which is the most important one here, which is the get participants, right? This is what decides who should view your state. So yeah, you would probably want to write a test case for that, and that's where you would just create an instance of it and then see if you have the correct number of participants and if they match the participants that you expect them to be. Pretty simple, not that much of complexities involved in the test cases for the state specifically. So I'll not spend any more time here. This is just very simple. Just one thing to keep in mind is the test identity. Apart from that, everything is plain old JUnit test cases. Right. So next, let's take a look at our contract. A contract can, the test cases for contract can get a little confusing for people who are looking at it for the very first time. It doesn't look like plain JUnit test cases. It has a few things which are very much Corda specific because we use the contract ESL or the test ESL to be specific. Again, we need access to parties, so we use the test identity. But the problem with these things, with the transactions, is testing your contract is exactly, you need a transaction, right? What your contract does is it checks your transaction, and then it needs to basically go through all these transactions. You need to simulate a transaction by some way. So that's what we do using the test DSL. So what it helps you to do is we could create services, mock services. What are these services? Is it sort of it's a mock for your service hub in a sense. So basically, it gives you those node services which is required to be able to test a contract properly. And why is that? That's because if you test a contract, basically you do a transaction, which means your transactions backchain also needs to be validated, right? Just a second. Yeah. So your transactions backchain is also needed to be validated, which means you would need access to the vault. So you need a ledger. So that's where the mock services is required. Right. And then a little bit of things about that I'll talk about in this particular test case, and then others are pretty much similar. Just walk through them after we just try and learn what's out here in this particular test case. This is pretty simple. All we are trying to do is check whether our contract that is written is actually an instance of contract interface, which is what we are doing in this test case. But everything after that, starting from here, is using most of the Corda libraries. So to simulate a transaction, what we have something called the node utils dot transaction, which is again part of the testing library. And then you could create a transaction using that. Now, again, coming back, how do you test a particular scenario? Like, for example, taking this one into perspective, you have the test case itself says token contract requires 0 input in the transaction. So what are the different cases that you want to test? The first case that you probably want to test is put in zero inputs and see whether your transaction passes, whether your contract allows the transaction. And then put in input, which means you're testing for a negative scenario, right? You're trying to put an input and then you're trying to see whether your transaction is failing or not. So this is how you test a particular case. This is simple. For this one, it might get complicated where you have multiple different cases to test. So you could have more than one transaction, right? So that's here we have an example of such a case where, see if you're checking something like whether something is 0, right? So you could want to check whether something is positive. So you want to check if it's 0, if it's negative, and if it's positive. So 3 different cases that comes in here. So similarly, but just forgetting about how many cases that you want to test in your particular test case, how many different scenarios. But then for each of these, you need to create a transaction. And so let's look at how we create a transaction here. So first thing you need is you need to pass the mock services which we have created, because your transaction verification will require that thing to access the mock service to get access to some of the node services to validate your transaction chain. And then you need to construct a transaction. And how do we do that? We do that using this particular lambda here. So we could it's pretty simple. You just create a transaction object, and we have all these methods which says tx dot input will allow you to put an input, and then tx dot output will allow you to put an output, tx dot command will allow you to put a command. And that's majorly what you have, inputs, outputs, and commands when you test, right? So let's again take a look at what else we have here. So it gives you all these different methods which you could use. You could also put in attachments if required, right? And you could put a time window if required. So all these things which are part of a transaction are available with your TX object, your transaction object, which you create here. So yeah, that's how you could create a transaction. It's pretty simple. Just use the lambda to create a transaction. Use tx.input for the input, tx.output for the output, tx.command for the command. And what you do is you could create your test, your state which you're expecting in your input as your input, and then you could create the output which you're expecting and put it out there, the command which you're expecting, and then this is where we assert. So these two statements are different in the transaction, other than the fact that for one of the transaction which we have an input, and for the other we do not have an input, which is exactly the positive and negative cases which I was talking about. And this is where things are a little different. Tx dot fails, right? And then we have tx dot verifies. So tx dot fails is again like an assert statement, other than the fact that it asserts that the transaction is going to fail. And it says that I expect this transaction to fail. That's because I'm having an input, and my test case is trying to test for a case where my transaction should not have an input. And similarly, this verifier says that my transaction should pass. So if you remember, if your transaction doesn't throw an error in the contract or illegal exception argument in the contract, assume that it has passed. And if it throws an illegal argument exception in the contract, then we say that it has failed. So that's all it does. It just creates this transaction, gives it to the contract, and try and see whether we are getting an exception or not. And it fails if you have an exception, and it verifies if you don't have an exception. So that's pretty much it. That's what we do in the contract, right? And everything after that are pretty similar that we have done. Instead of checking for inputs here, we are checking for output. Similar case, we have an input where we say that for this, here in this case, we say that we have an input and we're expecting it to fail. In the second transaction, we don't have an input and we expect it to pass. We do similar cases for our output, where we put two outputs and then we see that whether it fails, and then there is one output, and then we see that whether it passes. The test case says that my transaction should have only one output, right? So a transaction with two outputs should fail, and a transaction with one output should pass. And if the entire transaction, if those two transactions do what they're supposed to do, then we say that the entire test case actually has passed, right? So that's what we do here. Similar cases happens way down here. We create different transactions and try to simulate what we are trying to do. So yeah, I think I'll not go into much details. I think we should get enough idea what we are doing here in the transactions block as well. So let's move on to the flows, right? Well, flows require something else apart from some mock services. Flows are supposed to be run between two nodes, right? So instead of, so a transaction can be simulated, or a contract can be verified using a single node. So you don't need to have two nodes to communicate, and then only then you could decide whether a contract is passing or failing. But things are different for the flows, right? To run a flow, there are counterparties. You might have two counterparties who are running a flow, and they are coming to a business decision depending on the outcome of that flow, right? So that's a workflow which they are running. So so here we would need a network, right? We need multiple nodes. We need a network to be able to simulate a flow, to be able to test a flow. So how do we do that? We do that with the help of a mock network, which which you could create using our testing framework, or the not the framework but the testing library, which Corda provides, the test DSL. So that's what we do in the initial setup part here of every flow. So if you looked at any of the flow test cases, you would see this setup section where you would have a mock network getting created, right? So this is like a very simple network. We don't have any other any other parameters which are tweaked over here, but I can show you. What I will do is maybe just go in here. Okay, all right. Maybe I'll just don't have the sources here. I'll just open up something else to show the sources. Right. Here you go. Here you go. If you look at the mock network, right? So this is the source code of the mock network, and it allows you to have a lot of different parameters. Like you could have the mock network parameters. You could have certain other things like whether you want to run each of your nodes in one single thread, or you want separate threads for each node. You could have your own. So there are certain default network parameters which comes in. You could also sort of try to put your own network parameters onto your network, and all these different kind of configurations which are available that you could use. But for the sake of simplicity, since most of you would be looking at for the very first time and trying to understand what's happening on, we'll use the defaults, and I'll leave it to you guys to try and experiment with all the different parameters that we have, and then try to tweak your network as per your liking. But then the point here is we need a network, and that's what your test DSL provides you to test your test cases, or to test your flow test cases. So we can initialize a network here, and then obviously a network isn't enough. You need nodes as well. So that's where we add nodes to the network using the create party node function, and you could invoke that. That will return you the nodes, and you get a handle of the node as well, right? So yeah, coming down, what does run network does is at times you might need to. So this is not a real network per se. This is a mock network. Also, the nodes are mock, so not all services are running properly. This is most of the services are either mocked or are in memory. So at times you might need, like, there are certain messages which are there, and then you want to sort of do. It's more like you would have this. What do I say? The outlook, right, where you have a send and receive function, which basically tries to see if there are any messages which has to be sent or any messages that has to be received, and try to sync up. So that's what your run network does. So at times when you if you look at these ones, we are just running a single sort of flow here, because we just have one flow to test in this particular case. But at times you might have multiple flows that for example, you have created one asset, and then after you created that asset, you want to do another transaction on that asset. So for that, you need to have one flow running, and then depending on the outcome of that flow, which is actually creating an asset on the ledger, you're going to run another flow. So in that case, you need to run the run network. What that will do is it will sync up the nodes, and then all those message passing can be done using run network. So yeah, we just call it to initiate that process here. And then so all we could do is we have a handle of the node here, and we could start the flow using the node start flow method. Again, creating an instance of the flow shouldn't be very difficult. And then all you know is once you start a flow, we don't get the results instantly, because that flow needs to run, and then we get a future, right? So your flow returns you a future object, which is returned here as well. And then again, using the run network here, which is what I said, once your flow is started, there are some message passing which needs to be done. So just to make sure that things are running properly, we can call the run network, which will just pump in all those messages and try to sync them up. right? And then if you say future.get, once so that wait till your flow is completed, and once that completed, it will return you whatever is supposed to be returned from your flow. For this case, if you look at this, we have a signed transaction which is getting returned. So the return type here for the flow is a signed transaction. So it's not just the signed transaction which you basically get whatever you return out of your flow. And then you can do whatever testing that you want to do. Like for this one, it's trying to test whether we have the correct notary or not. But that's not the case. You could just test whatever that you want to test in your transaction, like whether your transaction has the correct outputs, whether it has the correct inputs, and all those kind of things. So that's how your flows work. So yeah, so that's where we have tested out all these three things. We know how to test a state, which is probably the most simplest. There isn't much that you do there. And then we learned how to test your contracts, right? So yeah, let me pull out an example. I think I have it here. Yeah. So we'll before moving on to the integration test, just let me pull out an example of a flow test where we have multiple flows. So where we could basically um, try to test whether we have okay, um, whether we can test two flows simultaneously or not. Yeah. So yeah, this is, if you look at this flow here, what it's doing is it's trying to test two flows at once. So you could see I have two flows being run. One is the asset flow and other is the auction flow. So what this test is trying to do, it's trying to make sure that we have two flows. So the way it works is initially you create an asset on the ledger, and then the next flow is trying to put that asset that you have created on the using the create asset flow into an auction using the create auction flow. So it's pretty evident that you first need to have an asset to be able to test your auction flow. So without an asset, you can't have an auction. So you can't test the auction flow without an asset. So in this case, you need to test two flows together. So generally, not exactly test two flows, but you could have separate flow to test your create auction. But then when you create asset, but then when you test your create auction, you also need to run that flow in order for you to have an asset in the memory. So what that means is the mock network not just is it also having its own sort of in-memory database, which is storing these things into the nodes vault. So you are able to actually create states as well as pull them out of the vault and test them in the next flow. So that's what I want to convey to you guys, that it's not just when you create an asset, it's not just lost within the once you're out of the flow, obviously it's lost, but that once you are within the same test case, once something is put onto the ledger, it's still there till, so you can fire another flow on that, and then you could basically even run another flow to see whether whatever you have persisted using the first flow has been persisted properly, and you could also try to fetch that and create a new transaction out of that. Right. Yeah. So I have a question which says, which project is being demonstrated? All right. I'll put all the links. I think we have them in the slides as well, but I will put the links into the comment box. Yeah. So here are all the test cases that we have shown you. And for the other one that I just showed, the auction one, I'll just open that up and paste the link to you guys. Yeah, there you go. That's it. That's what we are using in this particular session today. Yeah, so we have done all our unit testing part. Let's have a look at how to do integration test, right? Okay, so we have an integration test class here. So how do we do it? What do you mean by first of all doing an integration test? Um, so what we did is we tested state separately, we tested contract separately, we tested flow separately. But how do we test them all together? They are all supposed to work together, right, in tandem. So how do we do that? So in order to do that, first of all, we need nodes, not just mock nodes, but probably near real nodes, so that all these could be tested properly. And we need to have sort of the RPC, the nodes RPC, um, the what do we say, the RPC proxy in order to be able to fire a flow. So what we'll do is we'll use the nodes RPC to fire a flow, and then we also need to use the nodes RPC to be able to vault the to be able to query the vault and see whether the flow that we have triggered has done its job properly or not. So whether has it put everything on the ledger in the correct way or not, right? So how do we do that? Let's look at that. So for that, we have something called as the node driver, which we'll be using. The node driver is something which will allow you to create in-memory nodes in your IDE itself, and then you could basically uh, it will also give you a handle to the nodes RPC using which you could actually even log. So you could actually fire a flow. And not just that, if you have something like an explorer, the node explorer, it could also log into the node using the node explorer, right? So let's look at that. So this is the part. Again, the test identities are similar to what we have been looking. We need test identities. So what we are doing is we're creating few identities. We are going to test it on 3 different nodes. So what we are doing here, I'll just explain that to you guys, is this part here is just creating our nodes. So we have 3 nodes, party A, party B, and party C. So we just use our driver, node driver, to create these nodes, and we pass in all the information about what are the nodes that we want. 3 nodes that we want to start, which is just party A, party B, and party C. These are the identities which we have already created. And then we are starting in process node. You could also start out of the process node. And then a few other parameters which I'll not go into the details. So a lot of different parameters there. You could just tweak it as per your liking and try to play with that, see what that does. That would be a lot of information to digest at this point of time. Let's go with the defaults, right? So this is more or less template code. Don't worry about what's written. You're just creating. So anytime you create a node, this is the code that you can just copy and paste. It will just create your nodes for you. So the DSL is required to create your node, the driver DSL, and then that will create the nodes for you. And point to be noted here is we are not creating the node tree, because whenever you create nodes using, even you create one node using your driver DSL, that will create the node tree by default. You don't have to create a node tree to test to do the integration test. That will be created by the driver DSL itself, or the node driver itself. And once you have this, you get the handles to the node. So once it's more like you get a handle to what are the different to different services of the node. Like if I just do this here itself, so you get all these different services or different functions which you could access. So you could guess the directory where it is, the GMX address, node info files, and all these, the P2P addresses, RPC address, and all these things out of the node handle. One important thing is it gives you the RPC. When you say get RPC, it gives you the Corda RPC ops, which is the proxy, right? Using which we could fire a flow, or we could do a vault query, and we to do all those different things which are exposed using the node RPC. Right. So first of all, again, I can get the party which has been created, or the actual identity of the node in the which has been stored in the network map using the node handles get node info, and then get legal identity, which will give me the node's legal identity that has been stored in the network which is just created. and whenever I need to pass the, for example, when I create the token, right, I need to pass who is the owner. So in that case, I could pass this identity as well. So again, that's what I'll be doing. What I'm doing is, so generally this is what you do in your in all your, just a second. This is what you do in all of your test cases, right? Or in, sorry, in all of your client code, right? You call the flow using start flow dynamic or start track flow dynamic, depending on what you're trying to achieve. Whether you want to track the flow for all the messages that, or all the progress tracker messages it's passing. So yeah, once you have the RPC, you could call it. And then what we are trying to do is we are calling the token issue initiator flow, right? Which means it will start the token issue flow, and it should store, it should basically run the entire flow, right? It should issue the token, and it should store it in its vault as well as the counterparty's vault. Who is the counterparty for this case? It's party B. And this part is where I run the flow, and then this part is where I try to query all the different nodes and see whether this flow has done what it should, what I expect it to do. What do I expect it to do? When I query the vault, I expect that I should have one token which is being created on the vault, right? That's what I do. I do a vault query, and what am I querying for? I'm querying for the token state. So I get a token state out of it, and I can do an assert to check the size of it, which is 1, because this is the only one that I have done right now. And then I could also look at the different aspects of the token, whether whatever I have passed is exactly that has been stored, right? Who is the issuer, whether it's party A, who is the owner, whether it's party A, who is the amount, what is the amount, whether it's 100 or not, right? Because 100 is the amount that I have passed in. So I'm just checking for the correctness, whether the first thing that I checked is whether it has been stored, token state has been stored or not. Next is whether it has been stored correctly or not. I can check similar things for B because B was also involved in the transaction. And if I'm doing an integration test, that means that when two nodes are involved, both of these should be storing it in their vault, right? So again, doing the same thing, just doing the query of the second node, the node B, and then storing them, and then checking whether basically we get the correct information out of that or not. Again, going to party C, party C shouldn't have anything, right? Because party C wasn't involved in the transaction. That's where the privacy model of Corda comes in. Someone who is not involved in the transaction should not have that state in it. Now you could choose to skip this, but since this is the very first one which we are doing, I want to just showcase this thing that showcase the privacy model of Corda. So yeah, you could write your integration test cases depending on what you really want to test. But yeah, that's how you do it. You could actually run the entire integration test in your browser. You could run nodes, you could start nodes, and then you could fire flows, you could query vaults, and you could see whether everything is working as expected or not. Well, yeah, that's what is integration test, right? I guess we are pretty much towards the close of this, unless we have any more questions. We have looked at all these things. We have looked at integration test where we just test with real nodes, right? These are real nodes which get spun up on the IDE itself. And then for that matter, you could, if you just leave it, you just don't stop that flow. Maybe put a breakpoint or something, and try to even log into the node if you want to. So even if I run this, you could see all that information here. Let me show you that. Should get there you go. It's more like running the deploy nodes where you are having all your we are getting all our network parameters. These are more or less defaults, which you could also change depending if you want to change, depending if there is a network which is different from the one that is getting created by default and we test it on that. Could actually do that. But if you go down here, yeah, you see these nodes are getting created and they're also advertising their addresses, right? Go down. Where did it go? Yeah. So you see, you'd have three different nodes, and all of them actually creating or advertising their different addresses: your PTP address, your RPC address, and your RPC. This is RPC admin address as well. This is what generally a normal node as well does when it gets started, right? So if you maybe just try to put a breakpoint somewhere and maybe just don't allow this function to end, and these nodes are kept running, then you could also log into this using Node Explorer. That's pretty much similar to what we are doing, because if we can get a handle to the RPC proxy, that means the node are actually working, and the Node Explorer should also be able to log into them. I'll not show that to you guys. You can just check that out on your own. But yeah, these are like real nodes running in the background, right? And they have a in-memory database, S2 database as well, and flows can be triggered using RPC, which we just saw. All right, so that's it from today. Unless there are any more questions, we can just wrap it up. Well, thank you so much for watching, everyone. I hope you get a good idea of what we do when we do all these testing. So we learned about all the different type of testing that we do. We do our unit testing using our state test, using our contract test, and using our flow test, using all the different libraries, or just the test DSL, which is provided by Corda, which makes testing all these things much easier. And you could also do integration test, right? So yeah, thank you so much for watching, and looking forward for the next one. So yeah, finally, don't if you're not on Slack, just don't forget to join there. It's a great place to be. We have a lot of for developers which you would love to meet, and then have a look at training. There are separate sections for all these things there, and you could learn at your own pace. All right, so with that, I'll take your leave, and I will see you in the next webinar. Bye bye.